Morning, everybody. David Shapiro here with a video about robotics. Let me kill Flux. There we go. Um, so today's state of the industry update is going to be about GPT-3 or large language models in general and robotics. So the first one I want to introduce is SayCan. So SayCan is, what is it? Do as I can, not as I say. This is an experiment to integrate robotics with large language models to perform the planning and actions. And so the key thing that they've done is they use large language models to plan actions and figure out what it can do through affordances and weighting. I'm not going to go through the whole paper, but I'll just kind of give you the high level things, and you can see it kind of doing its thing here in the background. Their page, this link will be in the comments. It's great. It walks you through the whole thing with demonstrations and examples, and it's wonderful. You even see it from the robot's perspective. It's pretty cool. So yeah, this is really great. I predicted that this would happen back when I wrote Natural Language Cognitive Architecture, and it was not long after that they started doing this kind of thing. So basically, this is a very early realization of I don't know if they took it from my work, but it is a natural language cognitive architecture. It is using natural language to think and plan. Now, one thing that's missing from this is that it has no moral affordances. It doesn't think about what's right or wrong. It's just doing a task. And that is by no means a criticism against this work. This work is phenomenal. It's setting the stage for future things, because eventually one of the things that you'll have to create weights or values for, or affordances, is something dangerous, right? Is there high risk? Is it low risk? Is it morally or ethically ambiguous? Is it objectionable? But by trying to assign numbers to things, that's how you get started. And there's plenty of other things within affordances that have nothing to do with moral or ethics. You can calculate things based on how much time it's going to take, right? So time is a cost. Energetic expenditure is a cost. How much money is it going to cost, right? There's all kinds of things that our brains assess the cost and like reward, cost, risk, and benefits, all automatically, very fast. Anyways, so this really sets the stage. I'm excited to see where this team and people who take this research go with it. I definitely recommend you check it out. They have a simulation version, so you can just download it and run it yourself. The other thing is this company, Engineered Arts. They have integrated GPT-3 with their robot platform, so it can have open-ended conversations. I'm not going to play the whole conversation for you. It's very clear that it's using just kind of some basic GPT-3 prompting so that it can respond to any question. I don't know how much they have solved in terms of long-term conversations, but hey, if they see this video, I'm happy to talk to them and talk about using semantic search for holding long-term conversations. Although I'm sure other people are figuring out long-term longitudinal chatbots. What's going to be interesting is when you have humanoid robots with long-format conversations and cognitive architectures for solving problems and following instructions. That's really like kind of what we're moving towards. And the Tesla bot, that's what they want to do. So Ameca is the name of, I think that's the name of this chassis. But the company is Engineered Arts, so you see they've got their robotic chassis. It's kind of in the uncanny valley of human forms, right? Especially because it's got this kind of like slightly curvy body, like almost organic. To me, it's a little bit unsettling, but it'll take some time. It is still very impressive just how sophisticated it is. You can even just kind of zoom in and look at the I don't know if it's pneumatics or hydraulics, but it's got connection points in similar locations to where human bodies do. So particularly, I'm interested in these long ones that connect to the bottom of the arm, because we have really long muscles that connect here, and actually if you pull down, it engages all the muscles in your ribs as well, and you can kind of crunch up your whole body. I did an experiment years ago where I was trying to make like complex joints with cheap parts. It's called Murphy. I think I've still got it down in my shop. Maybe I'll post some pictures of that. Anyways, it was not going to work because I couldn't figure out the musculature. Someone did recommend pneumatics. Anyways, I'm drifting. I'm getting off topic. So yeah, just wanted to show that SayCan, this came out just a few weeks ago, I believe. Let's see, their update as of 8/16. Okay, so the initial release was back in April. And then last month they did a bunch of open updates, rather. And then this was just released just a few days ago. So we can see that there's progress happening. There's multiple folks working on integrating large language models with robotics. The future is coming faster than you think. I am telling you guys. Like, yeah, we might not have like AGI solved, but as many people actually have commented on Twitter and other places, we don't necessarily need full AGI before these things are, one, useful, and two, dangerous. You don't need something that is super intelligent in order to put something like this inside of, say, for instance, a combat drone or a domestic, like, make a slightly smarter Roomba that you can talk to. Basically, kind of what the conclusion that I'm coming to, and this is nothing special, but is that AGI will be realized very slowly and in degrees. And this is why I started talking about artificial cognition is the goal, is because this is a machine that thinks. It thinks about how to solve a problem that you gave it. It only does that one thing, but it's thinking. And so then the problem is, how do you make it think more? How do you make it smarter or faster? How do you make it able to solve more problems, right? So this is a natural language cognitive architecture. It's a primitive one, but it's darn good. And then this guy over here, the Ameca robot, I don't know how much cognitive architecture is in it, but they're integrating it with a robotic operating system, and so they're working at it. And I think that history will record the deployment of large language models like GPT-3, like Bloom, like Lambda. History will record this as the inflection point where we actually solved that general purpose, open-ended computing, because that's really what it does. With the advent of large language models, we now have open-ended computing. So what I mean by that is you can have a system that it'll keep thinking, and it's not a finite state machine. It's not an infinite state machine where it's moving from one mathematical state to another. It's completely open-ended. In my other experiments, GitHub, there we go. So I'm reorganizing it. So I renamed this one the longitudinal study. So this was the experiment I did a few days ago, where I'm testing core objective functions for their for different paradigms for their longitudinal stability, and I showed that foundation models like DaVinci tend to be unstable, whereas fine-tuned models like Instruct series tend to be stable but less creative. Everyone knows that. So I just demonstrated it in a different way. Anyways, so what am I trying to say? I don't know. It's just very exciting, and I'm curious to see how all this work comes together on robotic platforms. Obviously, AGI does not need to exist in a robotic platform. That's just going to be the thing that you interact with. Personally, I suspect that the most powerful things are going to run in data centers in the cloud, and you're just going to have a terminal, just an endpoint, right? Like you're going to interact with it through your phone, through a smart home device, but its brain is going to be running up in the data center. And I mean, that's how GPT-3 and other large language models run now. They're too big to run at home. You actually need like several very large computers to run them. Anyways, so that's the state of the industry update. Is we've got this very exciting time where large language models are being integrated with robotic platforms. So we will see where this goes. Stay tuned. It's coming fast. Thanks for watching. Like and subscribe, and consider supporting me on Patreon. Have a good one.